This video will cover the following observations: temperature profile, layer and interface identification, layer hardness as well as grain form and size, moisture content, and yellow flags. We will also cover common issues experienced. You can refer to Chapter 2 in your trusty SWAG manual for all observations found in this video. Using a simple and repeatable floor plan is recommended when conducting snow profiles. Size may vary based on objective. For our test profile, we chose 2 meters by 1.5 meters, and with the depth going down to 15 centimeters below our layer of concern. The observation wall is slope parallel, and you'll need to choose the wall that will remain shaded during your observation period. The test wall is oriented perpendicular to the slope's fall line. The third wall can be used for the propagation saw test. Take time to make the corner adjoining the two walls clean and vertical so that you can easily trace layers from observations to tests later on. Don't worry if your test wall isn't perfect right now. Focus on the observation wall and keep moving. We acknowledge thermometers have a wide range of accuracy, and there are some limitations to using this tool. But a repeatable process is necessary, as temperature serves as an analog for vapor pressure gradients, and it is the practitioner's primary method for understanding the metamorphic regimes found throughout the snowpack. With your observation wall prepared and your tools cooling in the shade, you can begin your temperature profile. Starting at the surface, shade the instrument with a shovel positioned in the snow as shown. Leave this inserted while you take your measurements to reduce solar influence. We recommend using only one recently calibrated thermometer. Beginning with the surface temp, make sure the instrument has stabilized and record the value to the precision of the instrument. Keep your gloves on and measure each subsurface temperature in increments of 10 centimeters as you move down the observation wall. Keep the instrument oriented perpendicular to the slope. Allow the instrument to stabilize and record the value, and continue moving down. Extra care may be taken around crusts or very thin, weak layers. We show here what the temperature profile looks like in the upper 40 centimeters. Practice taking a full temperature profile prior to coming to the course. We are now ready to move on to layer and interface identification. This is the seasonal history of the snowpack at your location. In addition to visually identifying layers, using tools such as a coffee stirrer, a crystal card, and your bare hand, you can begin to determine the respective layers of your snow profile. Get a feel for what gives you the best feel, then always start with that. It is easy to get bogged down by layers that seem very similar. The issue can be complicated more by crust sandwiches or very thin layers in the snowpack. Take your time and be thorough, and do your best to capture the most important layers. Once you have identified all the layers in your profile wall, record them in your field book using the template provided. The online learning, as well as the Pro Fieldbook, provides a template. In each box that is shaded gray, you will record the height of each layer interface. We elected to put 0 at the surface since we did not dig to the ground. Conventions will vary depending on your operation. Please see SWAG for more details. As an observer, you will now take hand hardness, also called resistance. With your glove on, pushing at a consistent rate with identical force as you move through each hardness category, starting with fist, moving to forefinger and beyond. In new snow, this can sometimes be difficult. Testing adjacent layers to calibrate your senses may be necessary. For layers harder than one finger, using a standard pencil is preferred, but a mechanical pencil will do in a pinch. You can also use your pencil to test very thin layers and compare it to other hardnesses found in your profile. When recording hardness, Use the white rows located between the gray rows under the resistance heading in your field book. Accurately observing grain forms takes practice, but rest assured, everything you have done up to this point gives you essential context clues in deciding what grain you are looking at. The location of the layer and the size of the grain are good places to start. A pro tip is using a translucent crystal card that allows the grain to be backlit for better viewing. With the grains spread out across the card, use a 10 or 15x loop to isolate a portion of the sample and then determine the average length of the grain along its long axis. On this 2 millimeter grid, you can see these fresh precipitation particles are about 1 millimeter in size. It has been snowing this entire time, and you can note the branches of the stellar dendrites clearly visible here. Moving along through the layers, if you encounter a thin layer or one that is otherwise difficult to observe, take time to gather and examine several samples. While observing, consider things like ambient temperature, falling precipitation, or even your own breath, which could impact the grains you are looking at. Taking a few samples can be particularly useful with smaller grain sizes and with thin buried weak layers like near surface facets. With a clean sample, we can examine and determine that these are 1 millimeter decomposing fragments from the storm preceding the one we are currently experiencing. We are now down to a melt-freeze crust. This was the old snow surface prior to these storms. Using our crystal card, we can isolate and cut away a small chunk of intact crust to view under magnification. Looking at the sample, it's possible to see the frozen water that bonds the individual grains together. It is not easy to identify the distinct grain sizes of a melt-freeze crust, and many practitioners will not record it. However, Jemison's paper suggests that for yellow flag calculations, you can use 1 millimeter. Moving below the melt-freeze crust laminate, we see a 20 centimeter thick layer of rounded grains. Under magnification, you can clearly see how the grains have bonded and sintered together. These grains are less than a half a millimeter in size. Well, it's still snowing. Moving into the lower layers now, we have found a thin layer of facets just beneath an older melt-freeze crust. The grains actually bounce a little on the card. Under magnification, you can see they are about half a millimeter in size, and their edges are rounding. In certain places, you can see them starting to form bonds with their neighbors. With these mixed form layers, you can provide a secondary grain type and size, indicated in parentheses for recording. Ensure that your fieldbook template is completely filled out and that each layer has grain form and size written down. We have also been recording moisture content of each layer during our observations. Our snowpack temperatures support dry snow, and we have not seen liquid water between the grains, as in this example from a wet snowpack. Table 2.4 in the SWAG offers more details. We will also record the yellow flags for each layer and interface before we begin our snowpack tests. Bruce Jemison's article, Using Checklists for Assessing Manual Snow Profiles, can be found in the online learning for further reference. A few things that may trip you up are a couple common issues related to missing equipment like a loop or crystal card, disorganization and poor time management, and incomplete documentation. Our next video will cover snowpack tests required for the Pro 1.